All righty. Yes, this morning's video was supposed to be my last video of the year, but this lesson looked like so much fun. I wanted to do it with you. I love these type of questions. I love word problems, and I love ones that kind of sound like a riddle. They're fun to figure out. It's just a little puzzle. So let's do them together. You should have worked on them today to the best you could. And I'm going to help you now on the ones that were kind of confusing. You are in the third grade. Riddles are supposed to be confusing to third graders. That's just the way it is. They're confusing to adults. I bet your parents were confused by some of these, right? Don't tell them I said that. So let's do it together. I think they're fun. You know, I love math. I love riddles, so it all works for me. Let's see what we got here. Number 1, Marilee places her language book next to her science book. Okay, language by science. Her math book is next to her reading book, which is next to her language book. Okay, so we can put those in order. We have her math book is next to her reading book, which is next to her language book. So that makes it easy because those three went together. Math book is next to reading book, which is next to her language book. What is one possible order? There are different ways it could be, but if we do that, then we have to go back to that. What happened to science? Let's go back to the beginning. Marilee places her language book next to her science book. Okay, so I can put science here and language is next to science. This is one possible solution. You might have done yours differently, but as long as you can match, you can go back to the sentence and make sure that your books are next to the ones that it says in the word problem, then you're fine. Let's look at number 2. 3 friends will put their money together to buy a game that costs $5. All right, so we'll say the game is Monopoly, since Monopoly is the game of the day in my house. So they want to buy Monopoly, cost $5. Dexter has 5 quarters and 6 dimes. Okay, how much is that? 5 quarters and 6 dimes. Dexter has, so 5 quarters is $1.25, plus 6 dimes, $1.25, plus 6 dimes, that's 6 tens. 35, 45, 55, 65, 75, 85. So that is $1.85 from Dexter. Right? Now, Belle has 6 quarters and 8 dimes. 6 quarters is $1.50 because a quarter is 25 cents each, and 6 of those is $1.50 plus 8 dimes, that's 8 tens. So $1.50 plus 80 is $2.30. Oop, get rid of that question mark. All righty. Emmett has 5 coins, but we do not know what those coins are, so we're going to leave Emmett as a question mark. If they have 10 cents left over, what coins does Emmett have? All right, so they spent $5 on Monopoly and they have 10 cents left over. So that means that altogether they had $5.10. Now, $1.85 plus $2.30 is $4.15. I can't do the math on the board like I would if we were in class, but trust me, that's correct. You guys can do the math with a pencil and paper in front of you. So together, Dexter and Belle have $4.15. Emmett has 5 coins that needs to make up the rest of the money so that they can buy the Monopoly for $5 and have 10 cents left over. All right, so one of the coins is going to be the 10 cents left over, right? Emmett has to make up 85 cents. Well, what's one way we can make up 85 cents? Well, 3 quarters is 75 cents, right? So that's, he uses 5 coins. So 3/4 is 3 coins, and that's 75 cents. And 1 dime would make 85 cents. And then they would have enough money to buy the Monopoly for $5. And then they'd still have 1 dime left over to be the extra dime right here. They have 10 cents left over. So what's this guy's name? Emmett gives 3/4 and 1 dime to Dexter and Bell, and together they buy Monopoly for $5, and they had 1 dime left over. That one's pretty darn confusing. I give it to you, but that's why it's a riddle. It's supposed to be a game. You guys like to play video games all the time and try to figure out crazy things about how to get in hidden places and trapdoors and all kind of stuff. This is just a game like that, but for math. And I say it's fun, so you say it's fun because you're math warriors. All right, here we go. Rod, this one's really tricky. Rod is less than 17 years old. The sum of 2 digits in his age is an even number, and it's greater than 4. But both digits are odd. How old is Rod? Okay, this one is really puzzling. So the first thing I did was, just as I did in this one, is I set up some kind of like a little chart. I put these things in here, and then I could move them around to put them in order. I was prepared to add all of their money together. Here I made a number line from 1 through 17. And that was the best way I could think to do it. So Rod is less than 17 years old. So right off the bat, I know that he cannot be 17 because he's less than 17. So I can get rid of the 17. I'm now down between 1 and 16. The sum of the 2 digits in his age is even and greater than 4. What do I know if the sum of the 2 digits in his age? What do I know? I know that his age has to have 2 digits. That means I can get rid of 9, 8, 7, 6, 5, 4, 3, 2, 1. Now I'm left with these numbers. So he's one of these numbers has got to be his age. Okay. Next, it says the sum of the 2 digits in his age is even. So there's 2 digits in 10, 1 and a 0, 2 digits in 11, 1 and 1, 2 and 12, and so on. Each one of these numbers has 2 digits in the number. If you add the 2 digits together, it's even. All right. So is 1 plus 0 is 1. Is that an even number? Nope. 1 plus 1 is 2. Is that an even number? Yes, we'll leave it. 1 plus 2 is 3. That is not an even number. We're going to get rid of it. 1 plus 3 is 4. That is an even number. 1 plus 4 is 5. Not an even number. We're getting rid of it. 1 plus 5 is 6. That is an even number. We keep it. 1 plus 6 is 7. We get rid of it. We're down to 3 numbers. All right. The sum of the 2 digits in his age is even. Okay, so that's what we have left. It's a number that is 2 digits, less than 17, and the sum of the 2 digits is an even number. All right. This number is greater than 4, but both digits are odd. All right. So the sum of the 2 digits has to be greater than 4. All right, well, 1 plus 1 is 2. That is not greater than 4. We're getting rid of the 11. 1 plus 3 is 4. That is equal to 4, but not greater. I'm down to 1 number. And it said, but both of the digits are odd. 1 is odd, 5 is odd. 1 and 5 together are 6, which is an even number that is greater than 4, less than 17. So Rod is, I'm on the wrong side of it, 15 years old. Is that tricky? Yes, indeed, it is. It's a puzzle. Do your best. You are not supposed to get, I do not by any means expect you to get all of these correct. I just expect you to try your best, to know that they're supposed to be difficult and they're challenging you, and that is okay. Just like on the board in my classroom when I put up those challenge problems, this is even harder than number 6 and 7 on the board. Okay, these are like 10 and 11. But that's okay. It makes you think. You get smarter when you're challenged. You don't get smarter if everything you do is easy. You only get smarter when you're challenged. So let's learn some more. All right, Jan is 3 inches taller than Dan. Okay, so here's Jan. Jan's height equals Dan's plus 2 inches, right? 3 inches. Okay, Jan is 3 inches taller than Dan. So Jan's height equals Dan's height plus 3 inches. Okay. Ellie is 2 inches taller than Jan. Okay, so here's Ellie. Ellie's height equals Jan's height plus 2 inches. All right. Ellie is 54 inches tall. How tall are Jan and Dan? Okay, so here we go. Ellie is 54 inches. The problem tells us that. We don't need to figure her height out, okay? She's 54 inches. Now, Ellie is Jan's plus 2. So that means that Ellie is 2 inches taller than Jan. And if Ellie is 54 inches and she's 2 inches taller than Jan, that makes Jan 52 inches tall. And Jan is 3 inches taller than Dan. So if Jan is 52 inches and she's 3 inches taller than Dan, that makes Dan 49 inches tall. Okay? I know these are confusing. Just keep trying and keep an open mind, and whatever you do, do not get frustrated. Because frustrated is what happens when you're trying to make an array with a marker and you cannot, no matter what you do, make all of the circles the same size. But I decided it is okay, because if these were actual tomato plants, they wouldn't grow the same rate anyway. So I think this is just more realistic. I did it on purpose. Ha ha. All right, here we go. Haley planted 30 tomato seeds. Here are my 30 tomato seeds. I have 1, 2, 3, 4, 5 columns times 1, 2, 3, 4, 5, 6 rows. 5 times 6 is 30. I have 30 tomato seeds. 3 out of every 5 seeds grow into tomato plants. All right, so I have 5 seeds here, and 3 of these 5 seeds will grow into tomato plants. So, nope. I am picking you up. Okay, so if this is 5 seeds, 3 of them will grow into plants. Here's another 5 seeds in this row, and 3 of these will grow into plants. Here's another 5 seeds, and 3 of these are going to grow into plants. Here's another 5 seeds, and 3 of these are going to grow into plants. Each time you have 5 seeds, 3 grow into plants and 2 are duds. So 3 plants, 2 duds. 3 plants, 2 duds. 3 plants, 2 duds. 3 plants, 2 duds. And my battery is running low. Let's plug in. One more. 3 plants, 2 duds. So the question says, how many tomato plants does Haley have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Haley will end up with 15 tomato plants. What is the lesson you were supposed to learn from all these problems? Making a diagram. Make a table, make a chart, make a picture. It helps. You can't do this stuff in your head. You have to make a picture. Now this one is actually pretty easy. There are 11 scouts in a troop. Their van has 4 rows of seats, and each row holds 3 scouts. Well, that's just an array. 4 rows, 3 scouts in each row. How many scouts can the van hold? They have extra, sometimes in word problems, they give you an extra sentence to try to trick you that really doesn't have anything to do with the problem. In this one, here's your extra sentence that really doesn't matter. Their van has 4 rows of seats, and each row holds 3 scouts. So 4 times 3 equals 12 scouts. Didn't even have to make a diagram for that one. That's it. It's an array, 4 times 3. All right, number 7. The amusement park sold ride tickets in packs of 5, 10, 15, and 20 tickets. So they have these booklets, and some booklets have 5 tickets in it, some have 10, some have 15, and some have 20, okay? And these booklets are little tickets to get on a ride, okay? So your mom can either buy you a pack of 20, a pack of 15, a pack of 10, or a pack of 5. All right. So what would a pack of 5 tickets cost if 20 tickets cost $4? Okay, so what information do I know? I know that 20 tickets cost $4. That I know. What do I want to find out? How much 5 tickets cost? Right here. This is what I want to find out. So if 20 tickets cost $4, what's half of 20? Half of 20 is 10. What's half of 4? 2. So if 20 tickets cost $4, then 10 tickets must cost $2. If half of 20 is 10, then half of 4 is 2. So that makes sense. So 5 is half of 10. What is half of 2? What is half of 2? Half of 2 is easy. That would be $1. So we answered it. 5 tickets. What would a pack of 5 tickets cost if 20 tickets cost 4? 20 tickets cost 4. 5 tickets would cost $1. Now here's an extra question. What would 15 tickets cost? If 5 tickets cost $1, what would 15 tickets cost? Well, there's 3 5s in 15, and 3 times 1 equals just an extra riddle on the end there, because I know you are so excited about all these riddles. All right, here we go. Number 8. Morgan buys 8 packages of 5 bookmarks. Each package costs $2. How much did she spend on the bookmarks? Okay, in this problem, we have extra information we do not need to know. What is it? Look for it. Morgan buys 8 packages of 5 bookmarks. Each package costs $2. So we know that Morgan buys 8 packages, and we know that each package costs $2. What we don't need to know is how many bookmarks are in each package. That's not relevant information to solve the problem. It's interesting, but it doesn't help us solve the problem. All we need to know is that Morgan bought 8 packages, and each package cost $2. Simple multiplication. 8 packages times $2 equals $16. Easy. All right, last one. Madison can make 2 apple pies with the apples shown. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 apples. And with 10 apples, Madison can make 2 pies. Excellent. If she has 9 times as many apples, how many pies can she make? All right, well, I have 10 here, but Madison has 9 times as many. So if I have 10 and Madison has 9 times that, that's 10 times 9, and 10 times 9 equals, who knows the answer? Who knows the answer? Where are my math warriors? 10 times 9, easy peasy, 90. Now I have 90 apples. Whoa, that's a lot of apples. All right, if she has 9 times as many apples, how many pies can she make? So she has 90 apples, and she can make 2 apple pies with for every 10 apples. So 90 apples divided by 10. Let's see. No, I'm not doing that right. I have to think about this one, guys. Madison can make 2 apple pies with the apple shown. All right. If she has 9 times as many apples, she can make 2 pies for every 10 apples. Oh, Lord. Oh, okay. I get it. So she has 9 sets of 10 apples. I'm sorry, guys. It is getting late again, and I'm getting tired. She has 9 sets of 10 apples. So, and she can make 2 pies with every 10. So 2 times 9, 9 sets of 10 apples, and she can make 2 with each one. So 9 times 2. Can't find the equal sign. It's getting too late. Equals 18 apple pies. Whew, that last one was rough. All right, so for each of these, and if you could imagine making 9 groups of 10, so you'd have 10 apples here and 10 apples here and 10 apples here and 10, and you'd have 9 like that. And then you'd know for each one that you drew, you could have 2 apple pies from that one. So that it would end up being 9 groups of 10 and 2 apple pies per group. 2 times 9 equals 18 apple pies. Whoo! So down here, I will write, she can make 18 apple pies. I'm not personally a fan of apple pie. I prefer if she was making maybe a nice chocolate Boston pudding pie. That would be good for me. Anyway, we've gone through 1 through 9, and they are tricky. Yes, they are. They even tricked me. That last one got me for a minute there. But the point is just so that you, at the end of this, learn that it's best to make a model with when you're doing these tricky word problems. If I had a pencil and a pen in my hand, or if I was on the board, I would have made these 9 sets of 10 apples. And then it would just look crystal clear. If I'd had 9 groups on the board and I knew that each group made 2 pies, that's easy. 9 times 2 equals 18. The tables, the pictures, the charts, that is the key to answering these questions. Even this, by me marking out the part that was extra information, the tricky information that you don't need, that just that one mark right there made it simple. 8 times 2. Okay? So each one I did, even with my pitiful little circles here, each one I did, I used some sort of a chart or a graph or a picture, or just making like this would be a chart again if I was on the board. I can't do all that on here, but I would have made it into a chart on the board. Just having these little boxes that I could move around and put in order to answer number 1. All right. So do the homework. Do your best. Do not get frustrated if you can't figure it out. It's okay. What you're doing right now is learning. Do you have to be perfect? No. You just need to learn. And each time you try, you learn. All right. I'll send the corrections out for the homework on Friday. I'll talk to you guys then, I guess. I won't see you. I'll talk to you. I'll do something with you on Friday. Bye, guys.